everyone, today I'm going to be holding different colors of plasma balls in my hand. So I have here a glass tube filled with 99.9% helium. And what's really interesting is if I can just get the electric field around this high enough, I can generate a plasma inside of this. Let's give it a try. Now let's increase the voltage around my fingers to tens of thousands of volts and watch what happens. There we go. Whoa, it's lighting up. Look at it go. Look how bright it is in my fingers. So it's not burning me at all. This is completely a ball of helium plasma. So helium gives this characteristic pinkish glow. Let's see what the other noble gases look like. Here's a tube of neon. Look how cool that looks. So this is the same gas that's in neon signs. Look at it just glowing in my fingers with no electrodes connected to it whatsoever. Then let's get our argon. Now the argon gives that pretty purplish color. And then this one is krypton, similar in color but a little more bluish. And then this last one is xenon. Not quite as bright, and it has that almost yellowish bluish glow. So how did I get the voltage around my fingers to be tens of thousands of volts? I have my mini Tesla coil here. And it's actually creating a high voltage between me and the coil here. Now if you remember, neon gas and these other noble gases are actually the gases that are used in neon signs. And the reason is because they're really easy to turn into a plasma. But here's the weird thing about it. Why are they so easy to turn into a plasma if they're so hard to ionize? If you remember anything from chemistry, the noble gases have the highest ionization energy, meaning it takes a lot of energy to knock an electron off of that atom in order to ionize it and create the plasma. So in order to generate a plasma, you have to rip the electrons off the outer shell of an atom. And that takes some energy. Now what's really interesting is that the oxygen molecule takes only about half the energy to rip an electron off of it than a helium atom. So it would seem that it should be easier to make a plasma out of oxygen than helium, but that's not the case. Let me show you. So you'll notice with the helium how far away I can be from the Tesla coil and still generate a plasma in this helium vial here. So you'll see it's already glowing, and look how far away I am from the Tesla coil. I can even bring it back further and you can still see a little bit of plasma glowing, and then it turns off. Now, in order to represent oxygen, I'm just going to use a syringe with air. So I'm just going to use my syringe here and create a vacuum in it so it's a little bit lower pressure in there, and that will help it create a plasma better. Now as I bring it close to the Tesla coil, you'll notice that there's no plasma being formed until right when I get close to it. Now you can see it. And also in this hand I have helium, in this hand I have xenon. So xenon is way easier to be ionized than helium, but watch what happens when I bring it close to the Tesla coil. Look, the helium turns on almost right away, and the xenon doesn't turn on until right here. So if it takes so much more energy to ionize helium, then why can it create a plasma so easily? Remember, a plasma is just atoms that have been ionized. So it would seem logical that something that's harder to ionize would be harder to make a plasma out of, but that's not the case. But to understand why this is the case, first we have to understand how a plasma is made in the first place. A plasma is made when an electron gets ripped off of an atom. And after that, because the electron is in an electric field, that electron will be greatly attracted to the positive side of the electric field. So it will start speeding up, falling towards that positive side. And the further it can go without hitting anything, the more energy it's going to gain as it moves in that electric field. And once that electron hits another atom, then it can create this cascading effect of electrons being knocked off of atoms, so you end up with a bunch of ions in a gas creating a plasma. And when those electrons recombine with atoms, that's what creates the light that comes off of it. That's where the glow comes from. Now, in order to light that plasma in the first place, you need those electrons to have enough energy. So if an electron just barely pops off of an atom and doesn't travel far before it hits another atom, then it won't have gained enough speed yet. So you want a lot of space between atoms in order for the electron to get enough speed to knock an electron off of another atom. That's why it's really easy to create plasmas when you have low pressure. For example, here's what my Tesla coil looks like in regular air, and here's what it looks like in a vacuum chamber. That's because the time it takes for an electron to hit another atom is a lot longer, so the electrons can gain more speed, and when they do hit an atom, it can knock electrons off very easily and easily spark that plasma cascade. So with oxygen molecules, there's a lot of different ways that an oxygen molecule can absorb an electron without creating an ion. For example, an electron could hit it and cause it to vibrate in a certain manner, and there's a lot of different vibrational frequencies in which the oxygen can absorb an electron and start vibrating. And so there's a lot of energy that's absorbed by that oxygen molecule that doesn't generate ions. Whereas for helium, helium is just a single atom. It's not bonded to another atom, so there's not a lot of vibrational frequencies. And also the mean free path is very large, so the electron can go a long time before it hits another atom. And so what that means is that the electron can gain a lot of energy at the beginning, even though it takes more energy to knock an electron loose on a helium atom. Once that electron gains enough energy, which is pretty easy, then it can easily create this cascading effect that sparks the plasma and generates a plasma in the helium. So it's really counterintuitive. To make a plasma, you need ions, and surprisingly, the gas that has the highest ionization energy, it's hardest to create an ion, it's easiest to create a plasma with it. You can even have a mini lightsaber fight, helium versus neon. Hey everyone, thanks for watching another episode of the Action Lab. I hope you enjoyed it. If you did, don't forget to subscribe if you haven't yet, and you can also hit the bell so that you can be notified when I release my latest video. And check out theactionlab.com if you haven't yet to see the new Action Lab merchandise. And thanks for watching, and I'll see you next time.